So imagine wiring an entire stadium for sound, right? But instead of ordering like 2 tons of heavy copper cable to run back to a central closet, you just bring a spool of standard Ethernet wire
Mm,
and maybe a handful of boxes no bigger than a paperback book.
right. Yeah, because usually when you picture a professional audio setup, there's this expectation of a massive blinking monolith.
Yeah.
Just a huge server rack somewhere with, hundreds of heavy, thick cables spilling out of it.
Exactly. Every single microphone and speaker in the building has had to be physically wired back to that one specific room, which means if you need to add just one more microphone on the other side of the building, you are pulling hundreds of feet of new copper through the wall.
Oh, it's a total nightmare.
But today, we are looking at the exact technology making that giant rack of gear vanish. We pulled a product page from HDTVSupply for the QSC QIO-ML2x2 network expander, and it might just look like a spec sheet for a $733 piece of AV equipment, but our mission today for you is to extract the core aha moment hiding in these specs.
Yeah, we are going to explore how audio architecture is radically shifting from those clunky, centralized hubs to sleek, decentralized
All
networks.
right. Okay, let's unpack this. Before we can understand why this shift matters, we really need to know what this little device actually does.
Well, I mean, it's often called a highly intelligent digital extension cord, but it's really less like an extension cord and more like a local post office.
A post office, yeah, I like that. It gives you 2 mic or line inputs and 2 line outputs, right? So it takes the raw audio letters right at the source, digitizes them, puts them in standard envelopes, and just ships them over the network.
Exactly. The central brain doesn't have to manage the raw audio anymore. It just reads the mail.
Mm-hmm.
And what's fascinating here is the concept of decoupling.
Decoupling, right?
Yeah, by separating the local inputs and outputs from the processing core, you can place professional connectivity exactly where you need it. And you'd think shrinking the hardware means sacrificing power, but
Oh, wait, it doesn't.
no, this tiny box is still pushing 48 volts of phantom power for professional mics. Sending data over Ethernet is one thing, but delivering the consistent 48 volts needed for high-end professional mics alongside that data is, well, it's wild.
Without introducing nasty electrical interference, too.
Exactly. That is what makes this node a powerhouse.
Yeah, and, the microphone detection feature really stood out to me. Usually, tracking down a dead mic in a massive setup means testing 50 different cables with a multimeter to find the break.
Well, yeah, an absolute chore. But this box actively pings the network if a mic drops, which completely changes troubleshooting.
Wait, really? It just tells you if a cable goes bad.
Yeah, it actively monitors usage statistics and sends failure notifications right to the engineers. It's not just a dumb terminal passively passing signal. It's actively managing its own little corner of the network.
Wow, okay, well, here's where it gets really interesting. How does this decoupled box actually communicate with the rest of the system without creating a logistical nightmare? Looking at the connectivity specs, it uses PoE, and you can actually daisy chain up to 4 of these devices together.
Which is huge for saving space.
Right, but I have to push back here. Doesn't this just trade a rat's nest of thick audio cables for a rat's nest of network cables? I mean, you're still running Ethernet to every single one of these boxes.
Yes and no.
Like, how is pulling 4 Ethernet cables practically better than pulling 4 XLR cables?
If we connect this to the bigger picture, it's about the data bandwidth advantage. You aren't pulling 4 Ethernet cables all the way back to the main rack. Because it packetizes the audio into network data, you aren't fighting analog resistance over long distances.
Oh, I see. So you aren't running them all the way back.
Right, that is how you can daisy chain 4 units on one standard Ethernet cable without losing a drop of audio quality. You run one cable to a room and loop it locally between the devices. It actually consumes far fewer network ports overall.
Oh, wow. Okay, that makes a lot of sense. You completely avoid the rack clutter then. And because this lives in the QSYS ecosystem, you aren't manually routing physical wires on a patch bay anymore.
No patch bays needed at all.
You're just dragging lines between icons in their designer software to connect things.
Precisely. It is all about scalability. You can effortlessly expand a system without having to pull a single new cable through the ceiling.
So what does this all mean? I mean, it means modern tech is moving toward customizable, network-based modularity. It's about putting the exact tool you need right where you need it.
Yeah, whether that means using the included hardware to surface mount it under a conference table or just tucking it into a local rack, you aren't tied to the monolith anymore.
Right.
This raises an important question, though. If specialized audio networks can now intelligently decouple,
Hmm.
deliver power, and manage themselves drop by drop over simple Ethernet,
Yeah.
how might this decentralized node approach eventually reshape the physical wiring of our entire homes and cities?
Man, it completely changes the blueprint. That giant blinking monolith of cables really might just be a thing of the past. Keep an eye on those decentralized nodes. They are a lot smarter than they look.